Okay, so we're going to look at some integration by substitution. Sometimes when you're trying to integrate and you can't just do a simple integration, you can't use reverse chain rule. So for example here we can't use reverse chain rule because this expression outside the bracket isn't a multiple of the differential of what's inside, so we can't do reverse chain rule. So sometimes we use substitution to make it simpler. So when you get these in exams, you'll always be given the substitution you're going to use, but it will usually be this bit inside. It'll be the inner function of what you're trying to integrate. So first of all, we're going to find an expression for x that we can swap in for x, and we also need to replace that dx with something in terms of u. So first of all, a simple rearrangement will give you x equals u plus 5 over 2. And also if we differentiate to get du by dx, we get that as 2. So dx equals du over 2. Okay, so now we can substitute those in to get this expression. Now obviously that's a bit simpler because we haven't got a bracket to expand. So now if we simplify all that, we can take the half and the half outside of the integral to get a quarter outside, and then we can expand that bracket so we get this integral, which is obviously a lot simpler than the integration we had to do before. So if we carry out that integration, again just increasing the power by 1, dividing by the new power, then that gives us that answer in terms of u, but obviously we need it in terms of x because the question we were asked was in terms of x. So all we do is replace u with 2x minus 5, expand out our brackets to get that quarter into the rest of it, remember your plus c, and that's your final answer. Okay, so you just need to replace anything that's in terms of x, you need to replace so it's in terms of u, carry out your integration, and then you need to put your answer back in terms of x at the end. Okay, because this is indefinite integration. Next example, here we have a definite integration, so we've got some limits there as well. So this time you don't necessarily need to put it back in terms of x at the end. So we'll go through this one. So this time we're going to use a substitution again, which is the inner function. So we're going to say u equals x plus 2. So we rearrange that to get x. Obviously it's a fairly simple one. So we get x equals u minus 2. And then we're also going to need to replace the dx. So if we differentiate, we get du by dx is 1. So du equals dx. But then we also need to look at the limits as well, because the limits are values in terms of x. So we need to work out what they are in terms of u if we're going to do our whole integration in terms of u. So if x equals 0, we can sub that back into either of our equations connecting u and x. You get u equals 2, and if x equals 2, u equals 4. So now we can sub all of those values in, including the limits, and we get this. So now that's what we need to integrate. So what we can do next, we can integrate, we can expand the brackets out first to get this, and then integrate by adding 1 to the powers and dividing by the new powers. So here we have this expression. Now this time we don't need to put it back in terms of x, because we changed our limits so they're in terms of u. We can just sub those values in to get the absolute value, the value we're after. So if we sub them in, we should get 7.28 to 3 significant figures. So if it's definite integration, you don't need to put it back in terms of x, but you do need to change your limits so that they're values in terms of u instead of x. Okay, one final example, including a bit of trigonometry. So again, it's definite integration, and we're given the values we're going to sub in. So we've got x equals 1/3 sine theta. Okay, so if we differentiate that, we get dx by d theta equals 1/3 cos theta. So dx equals 1/3 cos theta d theta. Then we also need to look at our limits. So if x equals 0, theta equals 0. And if x equals 1/6, theta equals pi over 6. So we can sub those values in, and we get this expression. Okay, it looks quite complicated, but when we use our trig identities, we can simplify it down quite a lot. So we know that 1 minus sine squared is cos squared. And then we know that if we got cos squared theta to the power of 3 over 2, then using our laws of indices, that's going to become cos cubed theta. But then we can cancel that out with this theta here. So then we're going to get, we can take the third outside of the bracket, and then we get 1 over cos squared theta, which is just sec squared theta. Now when we come to integrate that, obviously tan theta differentiates to sec squared, so sec squared integrates to tan theta. Okay, and we don't need a plus c because it's definite integration, then we just sub those values in, and we get our exact answer, because the question asks for an exact answer, which is √3 over 9. So be careful when you look at this. If you gave that to 3 significant figures, you would lose some marks because it says to give the exact answer. Okay, so that's integration by substitution. Now go away and practice.